Hi, my name is VJ Primo, and today I'm going to be talking about the intermediate value theorem. What is the intermediate value theorem? Well, the intermediate value theorem it literally states if f of x is continuous on the interval a to b, if a number L is between f of a and f of b, then there must be an x equals c where a is less than c, which is less than b, and f of c equals L. In layman's terms, this means that if f is continuous on the interval a to b, that any x value in that interval will have a corresponding y value. Let's take a look at some examples. To demonstrate this, I will start with the function y equals x. As we know, y equals x has no holes, discontinuities, or asymptotes. This means that the IVT does apply. We're going to be acting as if a equals -2 and b equals 2. This means that any value between x equals -2 and x equals 2 has a corresponding y value. The next function I will be working with is y equals x squared. As you can see, this is largely the same as y equals x, because on the interval from x equals -2 to x equals 2, there are no discontinuities. The next function I'll be working with is y equals the square root of x. So with this one, this is the first one where the IVT does not apply, because as you can see, the value for x equals -2 doesn't even have a y value. So the function is not continuous and the IVT does not apply. The last function I'll be working with graphically is y equals 1 over x. So as you can see, this function does have a point at x equals -2 and a point at x equals +2. But within those two values, it is not continuous because there is an asymptote at y equals 0. So this means that not every x value in the interval does not have a corresponding y value, meaning that the IVT by definition does not apply and the function is also not continuous. But you may be asking, how do I do this without graphing? Well, to do this without graphing, we're going to be trying it with this equation right here on the same interval that we've been trying while graphing. The first thing that you're going to want to do is look for any discontinuities in the domain. So to do that, you're going to want to factor to find out any holes or asymptotes. So here you can see that these x plus 3's cancel out and it leaves you with x minus 3 over x plus 3. This means that the only discontinuity is that there is no value at x equals -3. Because you get a 0 in the denominator when you plug in -3. However, the IVT does still apply because -3 is not on our interval from -2 to +2. So every single value between our intervals still has a corresponding y value and the IVT still does apply.